All right, so when it comes to authentication, we've got encryption. Encryption is a key control for confidentiality, data privacy, and we use it in lots of different places. So we've got two main ways of performing encryption. Now, there are lots of encryption schemes, but there are two main approaches to it. The first one is symmetric key. This is kind of the, if you ever did coded messages when you were a kid, a similar concept where both parties have to know what the key is. And in a simple Caesar cipher, for example, you may just say, well, I'm going to move every letter up 6 in the alphabet, and that's my code. Okay? So someone receiving the message would have to know, switch it back 6 letters in the alphabet and decode my message. So that's symmetric key. Both sides know the key. Now, we visit lots of websites, maybe a new website we've never been to. So we don't have an opportunity to both know the key, and that's where asymmetric key encryptions can come into play. So basically what this does, the symmetric key allows us to transmit things fairly quickly. Asymmetric allows us to kind of figure out, before we agree on a final key, figure each other out and determine whether we are who we say we are or whether we have a valid key to start with. So the way symmetric key encryption works, and again, some of the distinctions between the two. Symmetric keys suitable for large data sets. So you would not want to use asymmetric key encryption for sending a video, for example, across the network. So generally what happens is both parties, when they originally sign on, agree on a symmetric key to continue the session with. And that's what happens when you log into Blackboard, when you log into your bank's website. All of a sudden you then develop a symmetric key, or you often hear it called a session key, that works for as long as you're on that website, or until you're inactive for a certain amount of time, or in some cases just a certain time limit. So Blackboard, you can't use Blackboard for more than 24 hours straight, even if you're active the whole time, without the key expiring and it asking you to log back in. Okay? Of course, managing symmetric keys would not be cost effective, just given the number of people that access different websites and so forth. So that's where the asymmetric key comes in. And basically, asymmetric key relies on what we call public-private keys. So we have a pair of keys, and we can use our public key to communicate with another party. They can use their public key to communicate with us, and then we use our combination of public and private key to negotiate a symmetric key going forward. So you often hear that called the handshake. As you log into the system or as you get to an encrypted website and figure out how to read it. So you'll often hear this called public key or two-key encryption. Now, this process does require some processing overhead, so as you see on the left, it's not what you would want to do for large data transmissions. All right? So authentication is that whole process of figuring things out. It could be through the keys, or it could be through my login credentials or my knowledge of my secret questions that I may have put into the system. Okay? So in any business, we need some kind of authentication method because we need to verify that someone that we think entered a transaction or authorized a check or sent a wire transfer from one bank account to another actually did. So basically making it strong enough so that we can't repudiate it. So encryption, authentication, both the sender and the receiver use that two-key method at the beginning to authenticate. And then one of the two generates that session key. The session key is distributed using asymmetric handshake methods so that someone else can't intercept it. And then once that session key is in both parties' hands, then that becomes the key that's used going forward. Now, one other thing is called a digital signature. You'll often see this for actual documents that you want to attach a digital signature for. So in this case, digital signature, we call it a message digest of the document itself. So the document itself gets encrypted, we add our authentication to it, and that way any changes that might be slipped into the document itself could be discovered, because then the digital signature, that message digest, would not match the encryption anymore. So the document creator has to use a key to create, add their authentication to it, and then that also authenticates me as the creator of that document. Any changes added to that document between the source and the destination would then invalidate that key, that digital signature. The digital signature would no longer work. So here you can see a diagram of how that digital signature works in action. You can use it with all kinds of documents, even PDFs. You can digitally certify a PDF that you send so that they can be sure that it hasn't been changed by someone else. And here's kind of a play-by-play, step-by-step approach to how that digital signature process works. So when it comes to different types of encryption and authentication, we've got the digital certificate we just talked about, but we also have something called a certificate authority. So this is something that allows us to put an encryption key on our website that allows us to have a secure website. So these are different kinds of companies. Obviously, ISPs have them, but companies like Norton also sell them or manage them for you. I believe KPMG was even in the business for a while. I don't know if they still are. They were the only one of the big four I knew of that was doing it, but there could be others. And so the certificate authority, whoever is managing that key for you, once you have it, you can actually manage it yourself, but it requires some pretty good information security skills, so it's generally best to leave it to an organization such as your internet service provider or someone that specializes in that to take care of it for you. So you have your digital certificate, and then you use basically what we call the public key infrastructure, which is basically a set of agreed on policies, key mechanisms, and algorithms and things like that work for the web. You know, if I used Chrome and you used Edge and someone else used Safari, and they all used different ways of encrypting and decrypting, they wouldn't all be able to read the same website. So that's the whole idea going on there. So the public key infrastructure is basically a set of protocols that allows everybody to communicate with everybody else in a secure manner.